Hello, hello. Welcome everyone to the Land Tamer stream. It is Sunday night, the end of a weekend for some, the continuation of a 3-day weekend for those of us here in the U.S. We have Labor Day tomorrow, so that's kind of cool. It's a Sunday night, but feels like a Saturday night. I think my wife and I are about to watch a movie here in a little while after I finish up this lab. So, and also I have a little, imbibement here to kind of kick the night off. We just went out to eat and just settling down here for a little lab. I told her, I want to get home. I got this lab I want to do. I got a stream today, and then maybe we'll watch movies. So anyway, this is a really cool shot I saw on NASA's Instagram, and it's about the just swirling cloud formations of Jupiter. I'm so in love with Jupiter right now, folks. Like, I want I want one of those globes, textured globes that you can have of Jupiter. I would love to have that, man. But yeah, hey everyone in the chat. We got Callum here that we know of so far. And Callum and I have been talking about rstp. We've been talking about spanning tree protocol. We've been chatting about dummy Ethernet multicast frames. And there have been some interesting developments. I tell you, spanning tree protocol and rapid spanning tree protocol have never been this interesting to me as they are now. Except maybe when I first started studying my CCNA, I was like, wow, this is cool. And reading Radia Perlman's book, Connections. But looks like Callum and I are pretty much around the same sort of track right now, which is cool. I wanted to ask you about that, Callum. I meant to ask you on Discord, like, what material are you using? Are you using a particular workbook or an outline of some kind? I'm curious where you're at, because it sounds like we are like neck and neck, because I plan to work on MST tomorrow too. Anyway, we've been going back and forth, and I wanted to cover some of that today, because I'm getting into rapid spanning tree, and tomorrow hopefully multiple spanning trees, which is cool. I love this technology. I hate to admit it, but I actually really enjoyed studying this today. I spent a good bit of the day. I had to do a bunch of errands and stuff, and some shopping and groceries, but I still got in a good bit of time reviewing rapid spanning tree lesson in networklessons.com. But one thing I learned while studying rapid spanning tree protocol is it helped me actually clarify some of my understanding about spanning tree protocol, classic. That's what they call networklessons.com. Renee calls it classic spanning tree protocol. I sometimes refer to it as 802.1d, but this is going to be my second clarification on what I've said on stream about spanning tree protocol max age timer. And I thought I explained it better yesterday until I studied rapid spanning tree today, and I'm like, well, actually that's not even working the way I thought it was working yesterday, which is good. And this actually leads into sort of a larger theme, which is, one day I may go back and just tweet out to Cisco and say, you know what, Cisco, thank you for failing me twice, or allowing me to fail, or showing me that I needed to become more of an expert on these protocols. Because what I've learned on layer 2 protocols the last few days, I don't know, it doesn't seem like I had this level of understanding before, especially with rapid spanning tree. I just kind of glossed over rapid spanning tree, and just digging into it more today, I'm like, wow, I really did not understand how this worked before. So, thank you, Cisco, for failing me twice. Because you're going to make an expert out of me, one way or another. Anyway, so what I learned about spanning tree today, and the max age timer, it was a statement that Renee had in the networklessons.com for rapid spanning tree. He said that spanning tree protocol is a timer-based, quote-unquote, bridging/routing protocol. I still sort of think it's, has a lot of similarities to the way routing protocols work. But classic spanning tree is more of a timer-based, whereas rapid spanning tree is more negotiation-based, and to me, sort of more event driven. So, for example, with spanning tree, the max age timer, what happens, and I'm going to just clarify this, and you know, again, folks, this is one reason why I always say my channel, my content is not a teaching platform. Okay, my channel is a vlog journey. You know, it's about the journey. Because if you would have taken yesterday's blog as authoritative on how spanning tree protocol and max age timer works, then you would be wrong. Again, this is all about the journey, right? So let's say we have, I'm going to try to explain this again. Let's say we have, you know, this is your root bridge here, switch 1, and then you got switch 2, switch 3. And you have these links. And I need another set of switches here. 20 hops for bpdu and 802.1d. Yes, and I explained that incorrectly yesterday. And this is fundamental. Like, this is fundamental stuff. All right, so let's follow the bpdu. So switch 1 sends bpdu to switch 2. And I showed you this yesterday. Yeah, Callum says, I also found out that there's a max message age of 20 hops, apparently. I've not labbed 20 switches to test it. All right, so here's, and again, reading about rapid spanning tree clicked it for me about classic spanning tree. So let's take, actually, we're going to call this switch 4, switch 3, switch 5. Okay, here comes Mr. bpdu, and we'll just use our data thing, right? All right, switch 1 transmits. You know, we've already completed our root bridge election. Switch 1 has won the election. So switch 1 is going to start sending bpdus, or we're going to assume single VLAN 1 here, down its designated ports. And all designated ports on the root bridge, all ports are designated ports. So it sends it here and it sends it here. When it sends its bpdu, the aging, or the max age, is 20, and the age on this bpdu is 0 seconds, right? All fine and good. I showed you this yesterday in a pcap. All right, switch 2 receives the bpdu, and then switch 2 will forward. Now this is what I was getting wrong before. Is I was thinking for some reason that if switch 2 stopped receiving, like if it missed, I used to think 2, but it's actually really 3 in rstp. If he missed 3 bpdus, that's when he would time out and consider this port as a topology change. He's no longer receiving bpdus from switch 1. That's not really how that works in classic spanning tree. This is how it works in rapid spanning tree, and I'd gotten this confused. So this totally perverted my understanding of the max age timer, because in rapid spanning tree protocol, switch 1 is listening on this port for the superior bpdus, and the hello timer, he should expect one every 2 seconds. If he misses 3 bpdus, this port will be transitioned from forwarding to, I believe, well, that signals a topology change. And if this is an alternate port, for example, it will transition immediately to forwarding. That's how it works in rapid spanning tree. Okay, now let's go back to classic spanning tree. The way classic spanning tree works is switch 1 is going to forward a bpdu, And then switch 2, it is not going to generate a BPDU this way to switch 4, right? It is just going to relay the same BPDU. It's going to make a copy of the frame and forward it out any designated ports that it has. So this is a designated port. It is going to forward this frame or relay it. In rapid spanning tree, switch 2 generates a frame every 2 seconds. Whether he's receiving a frame or not, whether he's receiving the superior BPDU on his root port or not, he is going to, every 2 seconds, every hello timer, generate a BPDU down this way in rapid spanning tree. Going back to classic spanning tree, switch 2 is going to, every BPDU it receives, it will quote unquote relay or forward that same BPDU frame out of its designated port. Okay? And what it does is it increments this timer. Not the timer, it increments the age of that BPDU message. So the max age is always 20 unless you change the timer in your topology instead of 20, and you should change it throughout your topology, right? So unless you change it, if you reduce it down to 10, the max age will be 10 on every BPDU, right? Really, it's the root switch that is authoritative. So whatever you set it for on the root switch, you're effectively setting it for the topology, but you should make it consistent. But the max age is 20. So what happens is switch 2 relays this frame, increments the age to 1, so that when switch 4 gets it, he compares the max age timer against, the age of this BPDU and restarts the counter. If 19 seconds goes by, then he considers this port, he transitions this port to listening and learning, right? So that's the difference with max age. Max age stays the same. This is incremented. Each time it is relayed, so once this is sent to switch 5, for example, switch 4 will relay the same, all the information in the BPDU is the same, but it's going to increment the age to 2. And that's the thing, like if there's a delay, for example, let's say there's a delay from switch 2 to switch 4 for whatever reason. The interface is up, but switch 2, maybe it's having a processing issue or some other problem, but that's the thing. So as far as I know, when it forwards this from switch 2 to switch 4, it's still only going to increment the age 1. But by this time, if it took 19 seconds for switch 2, which would be a long time, right? If it took switch 2 19 seconds to relay that BPDU out to switch 4, and switch 4 receives it, and that timer, the last time it got a BPDU was 19 seconds ago, and this age is already 1, well, that's 20 seconds. We have a transition, right? This port transitions to a different state. So that's how the age timer works. And again, spanning tree classic spanning tree is based on timers, which I was like, wow, this is so cool. So that really helped me finally understand that, and I hope I've clarified that. One other thing I wanted to vlog about before we get into rapid spanning tree and doing the lab is these other frames that I saw. You may have saw me yesterday. This frame popped up, and I'm like, I'm seeing those from time to time here in Wireshark. And I'm wondering, like, what are these? And it's called decnet mop. Let me pull up I think I posted this on Twitter. I'm not sure if this is Twitter or Instagram. Let's see here. Yeah, I think it was Twitter. But I posted a link. I don't know if y'all saw it. I did post a link. Yeah. So here's the image. Yesterday we saw this destination address, AB0000020000. And this is deck management operations protocol or something like that, remote console. And I found a really good blog about this here. I love the title, Router Spring Cleaning, No Mop Required, by Dario Ciccarone, back in 2010. And he explains this whole thing. One, he basically says this is essentially, if you wanted to harden your switches, you would disable this, because this has been here since version 9. And it's actually a way, you'd have to be on the same broadcast domain, but you could essentially, and Linux contains a decnet. There's a decnet for Linux project, and most Linux distros have this available. There's a remote RC client. So you could essentially connect to your router, even if you disabled your VTY lines on a router. If this is running, and you'd still have to know the credentials, but you could use this protocol on a Linux box and remote into a router. So I don't know why they keep this running. I could not find any information about a use case. This is written back in This is written 8 years ago, folks, and it was old then. But every Cisco device, pretty much an Ethernet interface, is going to send out these protocols, these frames. Interesting little trivia. Moving right along. Labbing. So yeah, I wrote out a bunch of notes about rapid spanning tree and the differences between rstp and classic STP. There's a different BPDU version. And there's one thing that was really cool in Network Lessons, and I can't praise enough the Network Lessons lesson on rapid spanning tree. Just in a brief, short amount of time, I'm pulling it up over here. It really helped me clarify in such an easy to understand way how it's different and how it works and what it looks like. I didn't really feel the need to lab it, but I saw in Discord where Callum was saying, all right, there, I'm going to show just a brief, this is copyrighted, right? So I'm just going to kind of glance. He has an information here about these flags in a BPDU, and okay, Callum says, I think message age is just a hop count with a max of 20. Each switch keeps a record of the max age timer on all ports. Regardless of the message age timer, it has been 10 seconds since the last BPDU. The next inbound has a message age of 15. I don't think that triggers the max age timer. I believe the message age is literally just a hop count. It could be, Callum. Could be wrong, but that makes most sense to me. Otherwise, you'd have your 18th switch and the topology timing out immediately. Yeah, I almost want to say I read, I could be wrong. I almost want to say I read where it keeps a timer of the highest yeah, I don't know, to be honest. I thought I read something about this, Callum. That does make the most sense to me because, well, theoretically, you should only have a single root port, right? And if any inferior BPDUs, you would be ignoring in classic spanning tree. So you should have a single root port, and your root port would, of course, be authoritative. Let me just double check that. I don't think it's critical to know the difference one way or the other for the written exam, but curiosity. Let me pull up this networklessons.com on this max age. The message age is used to determine when a BPDU expires. You take the max age value minus the message age. So for this example, the max age for switch 2, he's going to look at what's the max age minus the message age of 0 would be 20. Switches further away from the root bridge will expire their bpdus sooner, right? He actually has a bunch of examples, like our switches will keep flowing the bpdus you've seen above as long as the topology remains the same. Yeah, I'm curious. I'm not curious enough to lab it, but that would make sense. And you know, I don't even know how you would lab it, because how do you delay a switch port without shutting it down? You could do a port packle, I guess. Put the packle in place, leave it in place for 10 seconds or 15 seconds, and then remove the packle. And you could also, like you said, lab it out with a hop count of 20. But good stuff, man. I love this stuff. This is awesome. I thought the message age was just an irrelevant timer as a hop count. Yeah, you could put 19 switches and then on the last switch, you know, I don't know. But just to kind of in the spirit of what I've been reading, that classic spanning tree protocol is timer based. Like everything is timer based. As a matter of fact, the calculation, like I was talking about the radius, I did read somewhere, and it may have been a white paper from Cisco about spanning tree protocol, and it was talking about the radius and saying 2, 15, and 20. That is all based on a max radius of 20, and assuming that you would not have that long of a delay in the transmission and reception of bpdus. But this is as deep as I've ever gone in spanning tree, and I never thought I'd want to get this deep, but like anything else, we're nerds, right? We're engineers. We want to know. We want to know. We want to lab it. We want to know how it works. But yeah, getting back to rapid spanning tree a little bit here. What was I saying about that? Rapid spanning tree, bpdus. So it's based on a max diameter of 7 switches. Okay. So do you remember reading about that? That would even allow, because yes, hello time is 2 seconds. I'd have to, yeah, my memory's a little fuzzy on that, but I do remember reading a lot of detail about the spanning tree radius and how you want to be very careful of not expanding your VLAN radius too far, because it's going to impose, especially, I remember the article saying, especially when you start adding quite a few VLANs and you get towards the end of that star, if you have a star topology, let's say switch 7 out, yeah, the number of calculations you're having to do when there's a topology change for each of the VLANs it can significantly impact the CPU and the processor. And you know, I've had this discussion before with others, and they think I'm crazy. Who cares about spanning tree radius? Like, you don't need to worry about that. But I have seen switches. If you've ever seen switching environments where you have like a lot of switches, and maybe not a lot of them, I was referring to this yesterday, maybe not a lot of them are using stack-wise, and you get to the bottom switch and you see there's not any VLAN filtering going on. So there's spanning tree instances, lots of spanning tree instances running on a particular switch. And once you get into a scenario, if you're not using like port fast on your edge ports, and you have links going up and down, you are asking for problems. And that's funny because you could have someone who's really versed in routing, who's really versed in a lot of the other protocols and configuring networks, and you could be having a layer 2 problem on your network and not even realize it. So max number 7 switches, you can manually change it. Yes, you can. Oh, so the max is 7. That's interesting, Callum. Spanning tree VLAN 1 root primary diameter 2 to 7. Huh. So you could make it smaller than 7. I guess a 7 is a default. You could make it smaller if you wanted to. Not sure why you would want to do that, but interesting. But I tell you, comparing rapid spanning tree to classic spanning tree, it's like 100 times better. A lot of these features that we talked about, you know, are built in to the design of rapid spanning tree. And if you're using classic spanning tree in your production environments, why? Go back and update them to use rapid spanning tree if you can. I really don't know of a use case for spanning tree unless you just had a really, really old switch that you couldn't upgrade for some reason. And if so, why? I mean, yeah, you definitely want to be using rapid spanning tree if you can. 7 is our calculated value. If you change it to 802.1d, it lowers all the timers down to match. Easier than changing each manually, yes. I see, okay. Cool. So, you know, rapid spanning tree is so much better the way to go. There are, you know, I guess in my mind before I was thinking, okay, a lot of this stuff is kind of automatic with rapid spanning tree. I don't need to really dig deep into how it works. But it is a lot different. There are a lot of differences between rapid spanning tree and classic spanning tree. And I'm not going to go over all those. I did make some notes. I'll probably share some of those out on the drill sheet. I mean, I made like 10 bullet points of how they're different. But what we want to do is watch this negotiation process because, as I already mentioned in rapid spanning tree, each switch is going to generate frames on its designated ports, copies of the BPDU frames every 2 seconds, right? So, as I said, even if there is a delay, and let's say it missed 2 BPDUs in 2 hello time cycles, it missed 2. Again, in rapid spanning tree, it will not transition or, you know, consider that there's a topology change unless it misses 3. But even if it missed 2, switch 2 will still have every 2 seconds transmitted or sent a BPDU, generated a BPDU down to switch 4 and switch 4 to switch 5, etc. That's just how that works. But what we're going to look at too is with rapid spanning tree, what's going to happen is if the convergence is a lot different. And I think what we'll lab here is we will lab a 3-switch topology. And I'm just going to show you the topology in Eve. So I have Eve up and running. Nothing's really configured yet. It's blank. But let's do this here. Naska, hello guys, you know where I can find some resources about spanning tree design? Oh, MST? Well, I will say, you know, when you say design, of course there is a CCDE track, right? Design expert track. There's a CCDA, a CCDP, a CCDE. I have not really gone down that track. I can't, you know, I don't know of a good resource for someone who is on the design track. But I will say, in terms of how the protocol works, if you're talking about MST, which is 802.1W, right? I believe that's right. When you talk about MST, multiple spanning tree, there are some very good documents in the Cisco docs. So I have used those in the Cisco documentation, and I'm going to be probably labbing this tomorrow, or talking about it, vlogging about it on stream tomorrow. So stay tuned. I'll see what I can find. I don't know if you've looked, Ness, because at the Cisco configuration guide, there may even be a white paper on multiple spanning tree, but Cisco does have some really good documentation on spanning tree. MST is S. Darn it. Okay, rstp is 802.1W. I always get those two wrong. Thank you, Callum. Man, I need to memorize that. That is on my drill sheet. I just need to keep working on that. Yeah. All right, here. Let's go back to... Let's just start all these nodes. I don't think they have the config from yesterday because I didn't export it, which is fine. I'm fine with that. But what we're going to do is we're going to simulate a couple of things. All right, let me make a little to-do list here. So first thing I want to see in the lab is I want to capture the negotiation process in bpdus. So the new flags. And let me see if I can pull up that article. I don't want to pull up the networklessons.com, which is, that has everything in it, right? But let me just find the Cisco documentation for rstp. If anybody has a link, feel free to just throw it out there. Actually, I need to go to, oh man, I get salty every time I come and they change things here. Unless it's for the better, which is not always the case. Let's just go to 2960. Support documentation, configuration guides. Let's do 2960, the software configuration guide. 12.2, let's go 15.2.4. Okay, configuring spanning tree protocol. Does it have rapid? Yeah, INE does have some lengthy videos on they're okay. They're okay. I've watched those. And now, I don't know if you're talking about the Callum. They have the written course, multiple spanning tree, and they have the advanced technologies MSTP videos, and the advanced technologies lab videos are pretty good. The written are just really brief, and the posts as well. They have some really good posts that are public, and then they have some really good workbook labs with detailed explanations. All right, configure spanning tree mode. This doesn't look like a very good... let's just look at, let's see, rapid spanning tree BP. Okay, this might be a good one here. 802.1W, 802.1W, 802.1W. Okay, here we go. Yes, this is what I want. So this is a good link, posting it here. I remember I've looked at this link before. This is actually showing This is kind of hard to read here. It's gray for some reason. Cisco documentation. I don't know what kind of reader they use, but it's no good. Like the navigational pieces of sorry, I'm trying not to get triggered going to the Cisco documentation website. Nobody wants that. All right. So what we have in the classic spanning tree protocol BPDU, and really, guys and gals, isn't it all about the BPDUs? When you look at spanning tree, it's pretty much about the BPDUs, because most of the information that you need to see what's going on in spanning tree, just like with OSPF, it's in the LSAs, right? With spanning tree, it's in the BPDUs. And in classic spanning tree, we have BPDUs, special BPDUs with these flags. And if you look at the IEEE BPDU, which, oh gosh, let me save this image and see if I can use a way to view it that normal humans would use, and that would be helpful to normal human beings. Sorry, a little sarcasm there, I know. So let's look at this PNG. Thank you. Ooh, horrible. Gosh. So much opportunity for teaching and instruction here lost. All right, so here's your BPDU, and you have, in this field here, you have, of course, the protocol identifier, the version field. So 00 is STP, 02 is rstp, the message type. So you have a configuration BPDU, a topology change BPDU, and rstp BPDU. And then you have these flags. And in 802.1d, as we see, we only use bit 0 and 7. This is one big difference, though. In rapid spanning tree, you use 0 and 7, but you have proposal and agreement. This is the negotiation we're talking about. So whoever thinks that they are the, switches have big egos, right? And whenever they think that they are the root bridge, which they're quick to do, they're going to send out, let me move that, yeah. They're going to send out a BPDU as a proposal. They're going to say, hey, I think I know who the root bridge is. I'm going to propose this. And what should happen is the switch should respond, I agree. That with the bit set, this flag would be set to 6, right? And in that case, the ports come up. And that should happen like very, very fast. So that's what I want to try to capture. I was speaking to Callum earlier, and he said he was having difficulty seeing these flags. Callum says, I just found something else that isn't mentioned anywhere. Posted in the Discord. Looks like it takes 2 times a forward delay for port to go from learning to forwarding if you don't have any BPDUs being sent on the port. I actually may have read that somewhere. Let me see, Callum. Let's go and look at the Discord. Oh man, so many messages. Good stuff. Okay, it takes 2 times forward to bring up a port from learning to forwarding if you don't have port fast edge enabled. Okay, so let's look at what you got going on here, because we're about to talk about this. Okay, did you change this here, Callum? Spanning tree VLAN 1 forward time 30. Okay, so 2231.21, you changed the interface. The line protocol went down 1 millisecond later. Or no, that's 1 second. That's the time, right? Hours, minutes, seconds, milliseconds. Okay. This one just got displayed first. Initializing port. Port is now designated. Okay, so that port became designated like right away. Then it transmitted a proposal. I think this is just latency in the messaging, the syslog messaging order or something. Because as we can see, this is all happening very fast. Transmitting a proposal. And it sends multiple, right? Okay, and it does a forward while. Now there are timers in Rapid Spanning Tree Protocol. It's not completely devoid of timers. But again, generally the building of the topology is not completely reliant on a lot of timers. But it does, when there is a transition like this, it does start a forward while timer that I think goes for 2 seconds. Look at that, forward while expired, and I think it does it twice. Generate that. So it takes 2 times a forward delay timer to bring up a port from learning to forwarding in Rapid Spanning Tree Protocol if you don't have port fast edge enabled. Yes, it generates a proposal every 2 seconds. Right. So it is not immediate, but if we look forward while, yes, there's a forward while timer. Okay, I'm going to read just a little bit of this from the lesson. And this ties in. I'm glad you brought it. This does tie into what we're talking about here, and we're going to lab here in a second. While. Okay, after switch receives a BPD from the root bridge, it immediately blocks all its non-edge designated ports. Okay. So let's say we have in our little lab here, sorry, I've not pulled that up yet, I don't think. Where's Chrome? Where are you, Chrome? Yeah. So let's say in our little lab here that we have switch 2. And we have a direct link failure here. All right, what will happen is, as this says, it will basically immediately, and this is a designated port. Actually, let's go over here. Let's go to switch 3. So let's say switch 3 has this port as an alternate. So it is discarding, right? Because in spanning tree we have discarding, learning, and forwarding, right? We have the 3 port states. So it's discarding here, and this port is marked as alternate. Now we have a direct link failure here. What switch 3 will do, which is different from spanning tree protocol, unless you're running uplink fast, is it will immediately transition this port to forwarding. Now, what it will also do is, let's say you have host 5 over here, and it is not configured in port fast mode, right? It's not in port fast mode. So it is considered and this is a well, no, that wouldn't show your point, would it? Yes, that's right. So this is a non-edge designated port. Actually, this is a non-edge designated port as well. If you had a PC here and in port fast, that would be an edge port. But on all, as it says here, it immediately blocks all its non-edge designated ports. As soon as it blocks its non-edge ports, the link will go into forwarding state. Okay, so yeah, as we see, root port goes down. This is a designated port. This is an alternate port. But since this is a non-edge, in other words, this could be a switch, it's going to immediately block and then as soon as it blocks, the link will go into a forwarding state. So it blocks it and then transitions to a forwarding state. That's why it's called rapid, right? Rapid spanning tree. But let's talk about this while timer. Okay, the while timer, and I had to look this up because I couldn't remember. The while timer is for the topology change. So what happens is, obviously, if this port went down, switch 3 is still going to send, I keep doing that, sorry. Switch 3 is still going to mark any bpdus. It's still going to flag the topology change. But it only does that on non-edge, right? It doesn't do a topology change if something is connected to an edge port, only a non-edge. And when it does that, it starts a topology change while timer that is twice the hello time. This will be done for all non-edge designated and root ports. And what that does is that's really more for not transitioning the ports, but it is all about, remember, when we do a topology change, we need to clear out our MAC address tables because we need to relearn what those are. We've got a topology change, so everything we learned up until now about which MAC addresses are where is not necessarily true anymore, right? So that's what the topology change is going to indicate, is that and what happens is this switch will immediately flush the MAC addresses that it learned on its non-edge ports. Remember, non-edge is connected to a switch, right? So everything it learned from this port, all the MACs it learned from this port, and from this port, it's going to flush them out. If there's another device down here and that's an edge port, it's not going to flush that. There's no need to flush that one, right? And then, as it says here, as long as the topology change while timer is active, it will set the topology change bit on bpdus that are sent out of these ports. And it will send one out its root port, right? Which is what we saw with uplink fast before. So let's look back at your post, Callum. Okay, so this might have been towards, okay, this is the same interface. I don't know why it logged that it expired twice, but it should have ran this while timer for 4 seconds, I think. 53. Yeah, I don't know about lining up all these timestamps. All right, now the proposal process. Let's talk about that. Let's go back to that. Because I think that is different from the while timer. Yeah, because you did a shut and no shut, that would have generated a topology change. So that's what the while timer is for. But the proposal, I think I agree with you here. Yeah, when a BPDU comes in, yeah, I don't know that he has in here what the timer is on proposal. selection of the root bridge in rstp is similar to stp in terms of the priority. I guess it would be too, though, because if you miss 3 bpdus, that's considered a topology change, right? I don't know. Let's see. rstp proposal bit. Oh, here we go. Proposal and agreement process. Okay, here's a detailed guide. This might be pretty good. CCI blog. This is a great blog site. You should be zooming like I want you to. I don't know what is going on in my zooms today, folks. Okay. Yeah, this site is great, man. I've gotten a lot of good stuff off this blog. All right. Okay, and this is probably what this actually means. They need to agree on which switch will ultimately transition a port to the designated role. Because you only have one designated port on each segment, right? Okay, so it's going to send, it looks like it's going to send proposals only when all non-edge designated ports, in other words, non-edge ports, are in the discarding state, except a link to switch one. Will the switch consider that the ports are in sync? At which point, switch 2 can then move the port into forwarding state and then see the PDU with the agreement flag set. Okay. So this is interesting. Let's go to this proposal process. This is what I wanted to capture in Wireshark. Well, we're frame hunters today, folks. Gotta hunt down these frames. And you said, right, Callum, you did not see these bits set in GNS3 using the IOSV L2 image. I believe I have the same image you do. Oh, wait a second. I thought you said you had 15.33? dir flash. Isn't that what you said? Oh no, you have the same. Okay, Cal's got some words here. I think my post is something else really. The TC wild timer is just a link that TC marked BPDUs are sent from the device. That's correct. It'll wipe all Macs on non-edge ports except the port the TC marked BPDU came in on. Yes. My output is just learning the forwarding timer, I guess. Forward delay times 2. Oh, because it does say FD, doesn't it? Sometimes trying to interpret debug statements is like reading hieroglyphics. There's no real clear documentation all the time on what exactly the message is intended to relay. So let's look at your output again, Callum. Forward while. Okay, I think you're right. See, I didn't read anything in the lesson about forward while. I just read about TC while. Right, okay. My output is just learning forwarding. Okay, I think you're right, Callum. You should have port fast edge enabled on ports. You don't expect to receive... Yes, you should. So my output shouldn't come up if designed correctly. True, very true. You're trying to make a point though, right? Can't ever see agreement set. However, a debug does show it setting the agreement. Yeah, it does look like an image DNS3 bug. That's what I wanted to help you find out. And that's what's got my curiosity piqued. So yeah, we have the same image, but the difference here will be that I'm running GNS3. I mean, sorry, you're running GNS3 and I'm running EvenG. So let's see if that is what the difference is, right? So what I'm going to do here is I'm just going to configure right now. I'm just going to configure the ports on each of these switches. Let's do switch 2. That does a pretty good job of scaling, actually. I never expect that to work really well, but that's pretty good. I like that. I wonder if I can... I still have to figure out my... I'm still new to EvenG, folks. I'm still EvenG Pro. So trying to get my rhythm down here. All right, switch 2. So we're just going to configure the interfaces. Then we're going to start a capture. And then we're going to watch this proposal process. So these switches are, you know, they're going to ask and hope that she says I do, right? Going to make a lifetime proposal here. Will they marry their... ports? Okay, so we got that. We're going to say interface range, yeah, 0. Sometimes these images act weird with ports that are like still up. So I like to shut them down, and then I do interface range, yeah, 0, 0. 0 to 1. Calum says, I'm just using CCNP switch OCG. I need Udemy and network lessons study, by the way, and some labbing dotted around. Hey, yeah, no problem, Callum. That's cool. So, are you doing network lessons right now? Because that's what I'm doing also. Well, I'm doing the network lessons CCIE routing and switching course, but I have a feeling that some of these courses have overlapping materials. To be honest, I never got this deep with Rapid Spanning Tree for CCNP. And I did great on the CCNP exam, and I did not know this much about Rapid Spanning Tree. So anyway, you're doing great, man. All right, I bought it today based on recommendation. It explains things so well, man. Plus, what I really like is the fact that, and I'm doing more labbing than I would ordinarily do, because I like, some people have these challenges, they can't find this or that, and I want to also lab that and try. As popular as Britney Spears, man, Britney Spears got nothing on me. She's old news, dude. She's old news show. I appreciate that, man. I appreciate that. Yeah, I really like the network lessons for that reason. It's just the explanations, and I'm telling you, like I said, on Rapid Spanning Tree, I've studied this many times, different formats. I've done labs with Rapid Spanning Tree. I've never understood as much as I did today just reading that single lesson on that site. It's awesome. All right, so what we're going to do here is switch 2, switch 3. We're going to change the, we're going to say interface range, GI 0, 0 through 1. Switch port trunk, incap.1q. Switch port mode trunk. I'm going to do no negotiate 2 just to Get rid of the noise. You know what else I'm going to do? Look at all those deck commands. I want to turn on this command to disable the deck. I want a clean Wireshark screen. Okay, that's all I want. I want it to be clean. I know I can use display filters, but you know, I like a tidy network. And I forget what this command is. No, that's not going to tell me anything. No decnet. All right, I'm not going to worry about that now. All right, that port is configured. Let's do the same on our other trunks. Interface range, JAS 0, 0 through 3, JAS 1, 0 through 3, a shut. Interface range, JAS 0, 0, JAS 0, 2. Switch port trunk, incap.1q, switch port mode trunk, switch port no negotiate. Yeah, man, thanks for popping in. Appreciate it, show. I know you got a full plate yourself, my friend. Watched you for a little while today, too. It was awesome stuff. Hope your INE workbook stuff was going well, the big labs. I'm curious to see, please show also, I would love to hear a report on how your lab performed today in Google Cloud. 16 routers, man. I know you had the switches off, you said. But yeah, I would love to hear how that went. I'm keenly interested in labbing in the cloud, and I think that's the future, what we're all going to be doing. Real curious, you know, of how that went. Let's see. Hellison Shooter, amazing to find a streamer doing networking with Even G. Yeah, man. Are you doing any streaming yourself? Heisen. Yeah, old man reading skills. Yeah, if you're doing something, that'd be great too. 20 devices on. That's awesome, show. Man, I was literally like looking at your topology, and a little bit of saliva came out of the one corner of my mouth because it was it's like I can't wait to be doing big labs like that with Jack and show. All right, so interface range, JAS 0, 0 through 3, JAS 1, 0 through 3. I know this might be a little hard to read, folks. I've not played with the formatting here. This is just the HTML5 console. So, I'm student network and security. Super cool to find an educational stream. Thanks, Lanterra. Hey, you're welcome, Heisen. Glad to have you. Yeah, if you want, this is our Discord. If you want to get in touch with other students of networking, we've got a wide variety. That's our Discord channel. And it's not just used by me. It's used by other streamers as well. And you'll see a lot of fireside chats going on in there about different topics. Come and join us. We're going to do switch port, trunk, incap.1q, switch remote trunk, switch port no negotiate. Okay, I didn't shut down those ports, did I? Inner range, JAS 0. Oh, shoot. Now I screwed it up. Shut. No shut. Okay. Okay, very good. No shut. I didn't no shut those ports either, did I? No shut. All right, so now we should have our trunk ports with VLAN 1. So let's just do a little basic verification. Show interface trunk. Okay, good. 0, 0, 0, 1. Let's look at switch 2. Okay, 0, 0, and 0, 2. That's good. 01 and 02, that's good. All right, now let's configure our host ports, because part of this lesson, part of this study lab is to observe the aging out of the MAC address tables. Yeah, you remember, I did mention, hear you say that, IOL. Probably so. I'm maxing out the free tier of Google. Yeah, that's what I was afraid of, Show, is that those big images would use a lot of compute, and that it would, all you would hear is cha-ching, cha-ching, cha-ching on Google's part, just eating away at that. That's what I was afraid of. And what I wonder about is, would it be, and that's why I'm so curious about this, because some of the other cloud providers, you know, like Packet.net, they will host you on physical hardware. And I wonder if that would make a difference in the consumption model. Yeah, don't be afraid. Definitely not, dude. Like Azure, I would love to. I'm watching other people too, right? But I want to make a chart of, and maybe we can work on this together, right? Or in our channel, Discord channel, our server, is I want a chart of, like, in my head I have Google, Azure, and then AWS, and then Blue Ocean, and then probably Packet.net. Blue Ocean will also do, you basically co-host hardware in the cloud. And they don't have a giveaway, though. I think Blue Ocean gives you $100. But what I'd like to see is just a chart, a comparison chart, kind of like what I did for home labbing software. You know, I did a performance chart of GNS3, Viral, and even G. And I graded on, you know, a number of different parameters and came up with an aggregate score. But I want to do that also with cloud and include cost, right? And just see how those compare. Maybe one day, just not a lot of time there. Josh Ledger, any rabbits answer? No way. Haha. You're gonna make Nightbot mad. Yeah, Packet, it seems like a good option. I saw you did a cost comparison chart, Show. I need to look more at that. Did you have some of the bare metal providers on there? Because I'm wondering, due to the CPU churn, if you're using bigger images, like a good baseline, I think, would be an image that most people could actually obtain. Like, very few people are going to be able to obtain the IOL image, but the rest of us are going to be left with either, you know, iOS, the viral images, or you could use, you know, the Dynamips images, or you could use, and again, those Dynamips images you have to obtain from, you know, gear you might have. And the other thing would be, what's the other? Is CSR. So let's check out your chart here. I did read your blog, Tony. I promise I did go through this. Okay, you've got the not free. Oh, there you go. Okay, so you've got it. True. Okay, here we go. Cloud My Lab. Yeah, I heard of them. The thing is, though, what is the cost of actually running? So your Google estimate. Would this change, Tony, now, based on... And this is running continuously. I would want something about, like, I mean, this is awesome, dude. I mean, when I saw this, I was like, this is what I was thinking about doing. And I loved it, but I was wondering about how this would change with your experience now that you've had a chance to run some different images. There you go. Awesome. That's what I'm looking for, show. That will help a lot of people like me. That's really going to help me, who I'm thinking about whenever I run it, because I have INE tokens for their racks to do the full-scale labs, but that's only going to last me so long. And at some point, I'm going to need to do it in the cloud. So, all right, folks, getting back to rapid spanning tree here. Sure, I think it's time to do another write-up. That would be awesome, dude. Really would help the community out, but I know you're busy labbing too. All right, my focus has gotten weird. There we go. All right, so we've got these. I'm going to configure these host ports now, folks, because we want to see the MAC address aging happen. 03, so we're going to say no shut. We're going to do spanning or switch port mode access. And that way, this will be an edge port once we go to rapid spanning tree. Sorry, that was switch 1, wasn't it? Oh, shoot. Shut. I need to worry about that. Let's go to switch 2. Do I stream about MPLS? Yes, I have in the past. If you look at I'm not a partner level on Twitch, so I can only save so many videos. But all of and I used to stream on YouTube, but all my past YouTube streams and all past, current, and future Twitch streams are uploaded to YouTube as well. So if you go to my channel, YouTube channel, you'll actually see, let's see, social. I have a command for that, promise. You will see, I actually have a playlist for MPLS. So check that out, that it might help. I've got Twitter. All right, but it's basically youtube.com/thelandtamer. So, and if for some reason you can't catch the stream live, I stream, my general schedule is Monday through Thursday nights, starting at 7 p.m. Eastern, and it varies on the weekends. It's once or more on Saturday and Sunday, and I usually announce it in the Discord channel. So, all right, we're going to make this again switch port mode access and no shut. We're going to do the same over here on this router, which we're going to treat it like a host. And let's just configure the routers real quick with we'll configure that interface. And it's just going to act like a PC. Also, if Heisen, if you're just learning about networking streams, here's a list, my friend. I would go to this list, and I try to keep track of all the streamers I know about. Show IP Interface Brief, who's up there, he streams every day, pretty much. He's doing lab streams, and he is on that list along with others. Give those folks a follow. And you never know who might be streaming MPLS. All right, this one is R5. Here we say interface GI03, IP address 192.168.1.5. No shut. That's going to be on our VLAN 1, right? Hey, you're very welcome, Heisen. Happy to help out, my friend. Number 4, interface GI03, IP address 2.168.1.4. Okay, so right now under classic spanning tree, these should be able to ping each other, right? 1.2, 1.6, 1.5. If we've configured everything correctly here. All right, might have an error. Jazz03, Jazz03, yep. Switch 3, show IP interface brief. Oh, I did 03 over here as access, right? All right, we've got 01, 02, and 03. That's right. Show span VLAN 1. I don't have to do VLAN 1, but all right, let's look over here and switch 2 then. Maybe our error is there. Can I combine these in Chrome? Like, can I put this... Show interface status. All right, 00 is trunked. 02 is trunked. 03 is connected. That's good. Okay, let's look at switch 1. Okay, that looks trunked. Show span VLAN 1. Designated forwarding, right? Show span VLAN 1. Root, alternate designated, that's right. Root designated, that's correct. So maybe it's on our ports here. Oh, it's down, duh. Didn't know shut there, okay. That should take care of that. All right, we got pings. All right, so we have basically classic spanning tree running. What we want to do is let's start a capture. And let's watch this proposal process. And what I should see here, let's say I capture on... What I'm going to do is I'm going to shut the interfaces down on switch 1, both interfaces. Then I'm going to come here, configure switch 2 and switch 3 as rapid spanning tree. I'm going to configure 1 as rapid spanning tree. I'm going to start a packet capture on GI00 here. And then I'm going to bring this interface up. What should happen is I should see proposal. And then I should see switch 2 send a copy of that same BPDU back to switch 1 with the proposal flag set, right? And then we should get BPDUs being sent with the agreement flag set. We're going to do debugs too, so let's write this out. This is our first task here, right? So we're going to shut down switch 1 ports. Configure topology as rstp, not router spring cleaning. Then we're going to, what else did I say? Begin packet captures on switch 1 GI00. Bring up the interfaces on switch 1. Okay, let's do that. So we're going to shut these ports down. And configure topology as rapid spanning tree, right? So do we know the command for that? Spanning tree mode rapid. pvst. Okay, we're going to say here, same. Spanning tree mode rapid. Oops, config t spanning tree mode. Let's go ahead and configure these as edge ports. Spanning tree. Actually, this is port fast. Spanning tree, port fast. And then right, a spanning. Spanning tree. Port fast edge. Okay, we're going to do the same over here. Interface GI03, span, port fast edge. Spanning. Why doesn't it like, why does span not work here? Oh, it's port that doesn't work. I should be typing out the whole command anyway as a memory exercise, but anyway, there we are. All right, so these ports are shut down. Yes, this spanning tree instance for VLAN 1 does not exist because we have no active ports. But what we're going to do is we're going to start our capture here on GI00. I've allowed my Labor Day allowance of, we got a little tequila in here, you know, to celebrate the holiday and to help our studies. And I've allowed my ice to melt. Oh well. Did I do the right port? I should not be getting any frames here. Okay, I'm a little confused. All right, this is interesting. All right, this is just a lab anomaly. I would know you would only see really in a virtual environment. Because we've shut down the port, yet we're capturing some frames on the port. Let's just chalk that up to virtualization, right? And these are so we've got, when you shut down a port on a switch image in the virtual environment, you're only shutting down outbound, apparently, because we are getting inbound frames, no problem. Because I just happen to know that's the MAC address here. The Ethernet address is switch 2, GI00. So let's just see what this looks like, okay? This is actually going to be interesting. So if we look at spanning tree protocol, we have the BPDU type is 002, and he should be saying he is the root bridge, which he is. Okay. And he's saying this is the designated. Okay, so what we should see here is when we turn this on, when we turn this port on, we should see switch 1 sending BPDU with this bit set first. Then, as I said, switch 2 will be sending the same BPDU back, saying, hey, oh, Callum, good call there. Shut it down on both ends. Yes, we could. It's funny, if you guys have seen the network lessons, this cracks me up. If I ever do a blog or something, I want to do it like Renee does it in his network lessons. He's got a very visual, like, chainsaw over the link when it's being torn down. So let's do that. Interface GI00 shut. Yeah, you got to shut it down on both. I mean, this is almost like a unidirectional link, right? I wonder if this would work for UDLD. As a lab, even though you can't, you know, physically disconnect the fiber. All right, so now we should not be getting any frames. Let's do stop and then start again. Okay, good deal. All right, so we're capturing. Let's see what happens. First, I'm going to do a base range, just 0, 0 through 1, no shut. And we'll do here. Oh, I didn't do my debug. No, it's spanning tree. How do we debug rapid spanning tree? Let me go back to the lesson here. He actually broke this out into 2 lessons. And one is just the principles, like the concepts. Debug spanning tree events. Yes, you're right. Yep, let's do it on this one too. The next lesson is actually configuration and debugging. Cool. I just love how that thing is laid out. It's so logical. All right, so let's look at our captures. And we just want to see STP. And here we have from switch 1. And I want to get into this a little bit, pvst plus for spanning tree, but all right, look at this, Gallum. I'm seeing proposal flag on both the Cisco format and the 802.1d format of the bpdu. I am seeing proposal. And later I should see agreement. I thought I filtered out. Oh. All right, let's look at 2. He came up. And he sends his proposal. So Callum, it must be a GNS3 thing. Must be a GNS3 thing. Because I'm definitely getting the flag here. Was it agreement you said you didn't see? All right, so notice here the root identifier. So this is basically proposal accepted. Switch 2 is basically reflecting the same bpdu back to switch 1 saying, okay, I accept your proposal. You are the root switch now. It's the agreements. Okay, it's agreements. All right. Drum roll. All right, let's go down to, I don't know how many of those it sends. Ah, I'm seeing the same thing. No, here's an agreement. So he's saying switch 2, sending to switch 1. Look at that, BPD. These are all the BPD flags that are set, and agreement is one of them. Now this one does not say agreement from switch 1. Is that because it's still waiting on the other port? Or does it not send the agreement flag? Is that just... GNS3, why do you fail me? Yeah, it looks like the agreement flag is only set by the downstream switches. It is only used by them. It is not used by the root switch. In other words, you always have to agree with me. I don't have to agree with anybody. Sounds like kind of how that works. Yeah. Notice that we're not getting any more bpdus, right, from switch 2. It should not send any bpdus back to switch 1 unless there's been a topology change. Yeah, he's like, okay, I bow to your superiority. You will be the boss. You are the manager of the Fight Club. Okay, so let's invoke a topology change. But this time it's going to be between switch 2 and switch 3. Which would be, which interface? GI02. I'm going to say shut. So now we should see a new bpdu coming from switch 2 up to switch 1. Okay, yeah, we've got, we skipped. There it is, topology change. All right, yeah, we had none for a long interval. I don't know if my timing is right. Okay, yeah, so this is where we got the TC. Now I've got the topology change, and it would have flushed the MAC address table for all non-edge ports. Okay, cool. What else? Trying to think of what else did I want to sort of... I wanted to find those things as part of this lab. That was my main goal. Oh, the other cool thing about the topology change in rapid spanning tree is that the topology change notification... Well, in spanning tree, we know the topology, the TCN, is sent up the tree only towards the root, to the root, on the root ports, up towards the root, and then the root port sends, or the root switch sends all its designated ports. It sends a bpdu with a topology change bit set to true. And then that's how everyone knows to, you know, adjust their MAC address table aging timer to the max age plus a forwarding delay of 35 seconds. So it goes from 300 to 35. Well, in rapid spanning tree, that happens faster. And basically, as we talked about, when the TC bit is set, receives a bpdu with a TC, it automatically ages out immediately any MAC addresses learned from non-edge ports, right? Except the one that sent that it received the topology change on. Then each switch in the topology will start forwarding bpdus to other switches, even though like switch 2 may say, okay, I have a topology change here. I'm going to send a bpdu. I'm not supposed to send bpdus normally, but I'm going to send a bpdu this way with topology change bit set. And I'm going to go ahead, why wait? I'm going to go ahead and send a bpdu this way also to let him know right away that there's been a topology change, right? Let's see. Yes, that's true. It tells the root. Okay, let's go. Then they both forward. Right. That's right. So rapid spanning tree is the way to go, folks. And it's so easy to configure that you definitely want... Oh, another thing that's cool is rapid spanning tree is backwards compatible with classic spanning trees. So if it receives bpdus with the older format, you know, like we looked here and under the bpdu type. If it's 0x00, then it just knows, hey, that guy's over there, he's a little slow, he's kind of old, he's a little behind the times, that's fine, we'll talk to him the way he needs to be talked to, and it will keep timers and everything and transmit classic bpdus down to down that way until now. Once it starts receiving a bpdu using this bpdu type, it will revert to rapid spanning tree again. So I really like it. It's cool stuff. And I think that's really all I have to show. I did want to see actually the debugs. So let me do this again. Just watch the transitions here. Interface GI03. We're going to say shut. Man, I don't think I'm seeing them. Let me just make sure that the network lessons wasn't using it, just maybe an older. Because I'm not seeing these events here. Yeah, this is the kind of stuff I want to see. Does it send the TC BPDU out a blocked alternate port? I think it only sends it on designated ports and its root port. That's a good question, Callum. Let's see. Also, it starts the while timer that we talked about. Once the switch takes topology change, it will start a TC while timer. And this will be done for all non-edge designated and root ports. So what will happen, think about this, Callum, in this particular environment, in this topology, let's say we shut down, that's how you detect an indirect. See, this is kind of, for indirect link failures and direct link failures, we have in classic spanning tree, we have uplink fast and backbone fast. Well, this new method of handling a topology change kind of does that. It takes care of that innately. And for example, if switch 3 is using this as a root port, okay, cool, yeah, because what will happen is if this port, if we have a direct link failure here, first of all, he's going to send a new bpdu with himself as the new root. The root bridge ID will be his. He's going to send it to this port because it's designated. All right, so this is, switch 3 is discarding here, but this is an alternate port, so it is listening, right? Listening is part of the discard. It's listening, but it's discarding. All right, so it will detect this new bpdu here, but because with the topology change bit set, so it's actually going to send a bpdu back up to switch 1 to let him know, hey, this guy's sending a topology change, but it won't transition the port here. Now, the transition mechanism for a direct link failure, so for example, let's say we have switch 3, everything's up and running rapid spanning tree, and we have switch 3 has this port in discarding mode, and it's marked as an alternate port. So what will happen is if there's a direct link failure here, in classic spanning tree with uplink fast running, this would immediately transition to a this would transition to forwarding. The same would happen for rapid spanning tree. So if this is a direct link failure, the alternate port will immediately transition to forwarding, and we'll send a bpdu up to switch 2 with our TC bit set. In classic, it would be a TCN, right? Also, what switch 3 would do in classic spanning tree with uplink fast is it would send those dummy multicast frames to let this guy know, hey, these are the Macs I know about. They're still available over here. So even though you time out in 35 seconds, you're going to time out your MAC address table because of the topology change. You could just know right away that this guy is over this way. But with rapid spanning tree, what's going to happen is when he sends a topology chain, a BPD with a topology chain, switch 2 receives it, he's going to immediately age out all MAC addresses that it knows about, except the ones it knows about from this port, because he knows this port is up. I think that's how that works. All right, so let's try to get our debugs here, folks. Let's see. Let's just make sure there's no rapid, because I'm seeing them on the Cisco Learning Network. No. Debug spanning tree. See, I've got MSTP here. It has its own. Oh, sync events. Oh, it did? I'm seeing other events, though. I'm seeing other logs. Show logging. Hey, thank you, Cal. Appreciate it, man. Good luck to you, too. You have inspired me, Cal. I probably would not have done this lab without your just trying to help, you know, trying to help us all keep our sanity on these virtual environments. You kind of inspire me to do this, so thank you, man. I appreciate it, and I know it's late for you where you're at, so good luck. Thanks for hanging out in the chat, and keep on keeping on, my friend. Sending you good bits across the globe. All right, so we're going to do debug spanning tree all here. Let's do debug span BPD. Oh, here we go. Maybe we don't want that. No. You all. I just type you all. Y'all. I'm seeing rapid spanning tree messages. Oh my gosh. You all. All kill GNS3. Okay, let's see what it does to even G. I'm going to give that time to hopefully sink in here. All right, and then we're going to do conft interface GI 03. Oh no, 0 interface GI 00. Shut. See if I get any rapid spanning tree messages here. Huh? You try that too, Callum. wait, was that the... No, that was not the... For a second, I thought I saw the dummy Ethernet multicast address, but it was not. Show spanning tree VLAN 1. Okay. Ooh, I still have this running too. Let's stop this. And I'm going to save this, guys, because I'll probably do, guys and gals, probably do a little... If you're not following me on Instagram and Twitter, every day I try to post something different on each, related to either pcaps or weird debug messages, or I'll throw a quiz out there from time to time. So definitely check it out if you're interested in that kind of thing. And this is rstp. Save that there. And I'll let you know when I get this loaded too, because I load these up into, I have a GitHub site where I keep these. Yep, it's just not happy anymore. All right, so let's go back to the vlog, folks. I think our labbing is good to go here. What else? Oh, trivia quiz. So, just before we close out, today's trivia is, what are the Ethernet MAC addresses for pvst plus, and number 2, spanning tree for bridges? As you know, the pvst plus is a Cisco proprietary, and it includes the capability of it supports like the all right, now I'm trying to enumerate this per VLAN spanning tree, right? So they diverge. You're going to see both. Typically, you'll see, like we've seen in these captures, you will see for each bpdu, you'll see one sent to both addresses, right, for compatibility. All right, so let's take a look at these, and I'm trying to think. I want to see how well I do. I think pvst plus is 000. CCC, CCC, 0180. I think that is a spanning tree for bridges. I'm guessing a little bit here, folks. Probably wrong on this. But the way you can find it is, I have a lot of this stuff in what I call the drill sheets. Or the drill sheet. It's a memory drill sheet that's out there on Google Drive. And I have a chart where I go through trying to just memorize a lot of this stuff. I have not done this in a while, so this is one of the hardest parts of the drill sheet to sort of memorize. With the flash card, you can actually flash up the entire address, right? And this is a little more challenging, though, because you're having to write it out. Because with the drill sheet, you have a fill-in page, and then you have the answer page. So you have to type everything out, and it's really, really helpful. No, I didn't get that right. Okay. All right, so the correct answer is 0100, and then 00CC CCCD. Native VLAN spanning tree protocol bpdu, and we are using the native VLAN in this case, right? The non-native, this is actually, I know I say non-native here, but this is the spanning tree for bridges. This 802.1d VLAN bpdu. I say non-native, but I probably need to reword these. So this is really pvst plus bpdu. Right, because we know the difference is the bpdu for 802.1d tags the native VLAN. 0180C2000000. Okay. Very good. I didn't have time to get a quiz together for tomorrow, but I'll bring one up tomorrow. Meat chunks. If you want to read the history, I already showed this earlier, of the decnet management operations protocol frame. This is actually an excellent write-up of this protocol, and I wonder if we see any in our pcap. I bet we do, because I didn't figure out how to turn it off. I already saved it, didn't I? Let me pull it up. Where are you, pcap? Oh, I better put in downloads, and it did. Put this on the desktop. Here we go. No filters. CDP, let's do, there it is. I don't even know what this time interval is. Like, is it every 2 minutes or something? But sure enough, AB 0000020000. Trivia, guys. It really is just trivia. But inquiring minds want to know. You know, when you see, you've done it before. When you open a, like if you do a Wireshark on your machine, and you do a pcap, and you're like, what is all this? You're going to investigate and see what they are, right? Anyway, I will share this out to the pcap GitHub later when I've got this synced up. And I think, folks, that we will end it there. Thanks so much for joining. Always appreciate the interactions in the chat and people viewing, stopping by to hang out. And you know, hang out with us in the Discord. Share your story. If you're not signed up, if you're not yet signed up there, number of great streamers and students in there, and we help each other out. You know, it's all for the community. Thanks so much for stopping by, folks. You can follow us on Twitter, Instagram, YouTube, GitHub. All the links are down below. If you have a Twitch Prime account and you have a sub sitting around, feel free to hit that sub button. Give us a sub or give us a follow here on Twitch. And we shall see you back here tomorrow at 7 p.m. Eastern Time here on the Land Tamer stream. Have a good rest of your weekend.